Beneath the surface of some of the world's most important waterways lies the evidence of a machine that changed the shape of nations. Not a ship, not a bridge, a machine. A 9,000-ton steel giant built to do something that had once seemed impossible: move rivers. For thousands of years, rivers controlled human civilization. They determined where cities formed. They decided where trade could flow. They separated regions from one another. They created natural borders that armies, merchants, and governments had to respect. A river was not just water. It was a barrier. And for centuries, humanity had to work around it. Until industrial engineering began asking a different question. What if the river itself could be changed? What if a machine could cut through the earth, redirect water, remove obstacles, and reshape entire landscapes? The answer was one of the largest mechanical creations of its age: a steam-powered excavator built to attack nature on a scale never seen before. Its buckets tore into soil and stone. Its engines drove enormous arms through the ground. Its operators transformed geography one load at a time. The machine helped create channels. It opened transportation routes. It connected regions that had once been isolated. And in doing so, it helped nations grow. But every new waterway came with another story. Because moving a river was never just an engineering achievement. It meant moving Earth, destroying old landscapes, changing ecosystems, and sending thousands of workers into some of the most dangerous industrial environments ever created. The men who operated these machines worked beside crushing mechanical forces. They stood near unstable ground. They managed equipment powerful enough to reshape the planet. The world saw the finished canals and waterways. It saw commerce expand. It saw cities rise. But the workers who built these changes remained largely hidden beneath the achievement. Today, the great steam giants are mostly silent. Some disappeared. Some became rusting monuments. Some remain as reminders of an era when engineers believed any natural obstacle could be defeated with enough steel and power. But their legacy raises a deeper question. When humanity built machines capable of moving rivers, did those machines simply create new nations? Or did they reveal the hidden cost of forcing the world to change? Welcome to History Forged. This channel explores the rise of industry, the evolution of engineering, and the people who worked inside the world's most powerful machines. If that sounds interesting, subscribe and join us for more industrial history and engineering documentaries. Before the great steam giants arrived, rivers were among the most powerful forces shaping human civilization. They provided water. They carried ships. They supported agriculture. They connected settlements separated by hundreds or thousands of miles. But they also created boundaries that human beings could not easily overcome. A river could determine the fate of an entire region. Where it flowed, trade flourished. Where it blocked movement, development slowed. For centuries, societies adapted to rivers rather than controlling them. Cities grew along natural waterways because rivers provided transportation and resources. Ports became centers of commerce. Merchants moved goods by water because moving heavy materials over land was slow, expensive, and difficult. A single boat could carry what hundreds of animals or workers would struggle to transport. Water was the easiest path. But the river had its own rules. It flooded. It changed course. It deposited sediment. It created shallow areas that blocked navigation. It separated communities. The same force that supported civilization could also limit it. As the industrial age expanded, these limitations became increasingly unacceptable. The 19th century created a new demand for movement. Factories required raw materials. Cities required food and fuel. Industries required reliable supply chains. The world was becoming more connected, but transportation remained restricted by geography. Railroads solved many problems on land. Steamships improved ocean travel. But inland waterways remained unpredictable. A river that was useful in one season could become nearly impossible to navigate in another. A channel that worked for small boats might be useless for larger vessels. As industry grew, companies wanted deeper, wider, more reliable routes. The challenge was that rivers were not designed for industrial economies. They were natural systems. They followed geological patterns formed over thousands of years. They contained obstacles that humans had to overcome: sandbars, rock formations, narrow passages, shallow sections, seasonal changes. For centuries, improving a river meant using human labor. Workers dug channels, removed debris, built small barriers, cleared obstacles. But these methods were limited. A crew with hand tools could only remove so much material. A group of workers could widen a channel, but slowly. A river system extending for hundreds of miles required something beyond human effort. It required a machine. The Industrial Revolution had already transformed many forms of labor. Steam engines replaced muscle in factories. Locomotives replaced animal transportation. Mechanical harvesters transformed agriculture. The pattern was clear. Whenever society encountered a limitation created by human physical ability, it searched for a mechanical solution. The river became the next obstacle. Engineers began imagining machines that could perform excavation on an unprecedented scale. Not machines that simply dug, machines that could continuously reshape the earth. This was a different challenge from ordinary construction. A building required materials to be assembled. A bridge required support structures. But changing a river required removing what already existed. The machine had to attack the landscape itself. The amount of material involved was enormous. To create a new channel, engineers had to remove millions of tons of soil and rock. To deepen an existing waterway, they had to excavate below the riverbed. To redirect water, they had to change the relationship between land and flow. The river was not just an object being built, it was a moving system. This made the problem more complicated. A machine could dig, but it had to dig in a way that created a functioning waterway. Too shallow, and ships could not pass. Too narrow, and traffic would be restricted. Too unstable, and erosion could destroy the work. Every cut into the earth changed the future behavior of the water. The excavation machine therefore became part of a much larger engineering system. It was not simply removing dirt, it was creating infrastructure. The need became especially urgent as nations competed economically. Waterways determined trade power. A country with efficient transportation routes could move goods faster and cheaper. A country without them risked falling behind. Governments began investing in canals, river improvements, and large-scale engineering projects. These projects were not only about transportation, they were about influence. Control of waterways meant control of commerce. Control of commerce meant national strength. The machine that could reshape rivers became strategically important. The steam-powered excavator emerged from this environment. It combined several industrial breakthroughs. Steam power provided energy. Steel construction allowed larger structures. Mechanical systems multiplied human strength. Together, they created machines capable of doing work that earlier generations could barely imagine. A single machine could replace enormous amounts of manual excavation. But the creation of these machines did not eliminate human involvement. It changed it. Workers no longer carried every load. They operated systems. They maintained machinery. They entered new forms of industrial labor. The machine became powerful because human skill was built into it. Operators learned the rhythm of the mechanism. They understood how it responded to different materials. They adjusted movements based on conditions. The steam giant was not an independent force. It was a human-controlled force, and the people controlling it faced new dangers. A machine powerful enough to move rivers could also crush, trap, or kill. The larger the machine became, the smaller the individual worker seemed beside it. Yet the entire operation depended on those workers. Without them, the steam giant was nothing more than thousands of tons of silent steel. The world needed these machines because the old methods could not keep up. Human labor could not reshape landscapes fast enough. Trade could not wait for nature to cooperate. Nations wanted new routes. Industries wanted new resources. Cities wanted new connections. The river had become an obstacle standing between the old world and the industrial future, and the solution was about to arrive. A machine built not to work around nature, a machine built to challenge it. But before the steam giant could transform rivers and create new possibilities, it first had to be designed, adopted, and placed into a world hungry for change. The steam giant did not appear suddenly. It was the result of decades of industrial experimentation, economic pressure, and engineering ambition. The world had already learned that steam power could transform movement. Factories had been reorganized around mechanical energy. Railways had connected distant regions. Steamships had reduced the uncertainty of ocean travel. The next challenge was obvious. If steam could move machines across land and water, could it also move the earth itself? The answer would change how nations built infrastructure. Early excavation equipment was relatively simple. Workers used picks, shovels, carts, and animal power to remove material. Later, steam engines were adapted to operate mechanical shovels and lifting systems. These early machines were revolutionary because they separated excavation from human strength. A worker no longer needed to personally lift every load. The machine multiplied effort, but the first steam excavators were limited. They could perform impressive work compared with manual labor. They could not yet match the enormous demands of industrial construction. The ambitions of the age continued growing. Governments wanted canals. Cities wanted water systems. Industries wanted transportation routes. The larger the project became, the larger the machines needed to become. The steam giant was created by this demand for scale. The goal was no longer simply to dig. The goal was to move landscapes. The machine had to operate continuously. It needed enough power to cut through difficult material. It needed enough capacity to remove thousands of tons. It needed enough reliability to support projects that could take years. This required advances in multiple industries at once. Steel manufacturing improved. Engineers gained the ability to build larger frames that could survive enormous forces. Mechanical systems became more efficient. Steam engines became stronger and more reliable. Manufacturing itself became capable of producing components larger than anything previous generations had attempted. The giant excavator became a symbol of industrial maturity. It represented a point where machines were no longer simply tools. They were entire systems. The machine contained power generation, control mechanisms, structural supports, moving components, human operating spaces, maintenance areas. It was a factory that could move, and its purpose was to transform geography. One of the most important applications was the creation and improvement of waterways. Canals and artificial channels became central to economic development. They offered a cheaper way to transport heavy materials: coal, iron, grain, stone, timber. Almost every major industrial resource benefited from efficient water transportation. A successful waterway could change an entire region. Towns grew along routes, ports expanded, industries relocated closer to transportation networks. The steam giant became one of the machines that made these transformations possible. But the machine itself was only one part of the system. Large excavation projects required planning, financing, and thousands of workers. The machine created speed. The workforce created operation. Engineers designed the route. Surveyors measured the land. Laborers prepared the site. Mechanics kept the equipment functioning. Operators controlled the excavation process. The giant machine stood at the center of a much larger human organization. The scale of these projects also changed political calculations. A waterway was no longer just a local improvement. It could influence entire nations. Trade routes affected economic power. Transportation affected military strategy. A country with better infrastructure could move goods and resources faster than its competitors. This created a race. Nations wanted to modernize. They wanted to prove they could command nature through engineering. The steam giant became part of that ambition. It was a physical expression of industrial confidence, a machine saying that obstacles were temporary. Mountains could be cut, rivers could be redirected, land could be reshaped. The limits of geography were becoming negotiable. But this confidence also created pressure. The larger the projects became, the more workers were required. Even the most advanced machines needed human support. The steam giant reduced some forms of labor, but increased others. Operating the machine required skill. Maintaining it required knowledge. Repairing it required specialists. And all of these workers entered environments that were changing constantly. Construction zones were unstable. Earth moved around them. Water levels changed. Machinery operated nearby. The machine created new opportunities and new dangers simultaneously. The workers who controlled these giants were among the first people to experience a new type of industrial relationship. They were no longer simply laborers using tools. They were operators managing forces much larger than themselves. Their mistakes could have consequences measured not in broken equipment, but in tons of earth collapsing or machinery failing. The machine demanded respect, because the machine was powerful, and power always creates risk. As steam excavation expanded, these machines became essential to some of the greatest infrastructure projects of the era. They helped cut channels through difficult terrain. They deepened waterways. They removed barriers that had existed for centuries. The results were often dramatic. Routes shortened, trade increased, cities connected, entire regions changed. But beneath every successful project existed a hidden reality. A river moved only because something had been removed. A channel existed because someone had cut into the earth. A new route appeared because workers and machines had transformed the old landscape. The public saw the achievement. They saw the completed waterway. They saw ships moving through spaces that had once been impossible. They saw proof of human progress. They rarely saw the machinery working for years in mud, heat, dust, and danger. The steam giant became famous for what it created. But its story was also about what it consumed: fuel, materials, time, and human effort. The machine promised a future where nature could be controlled. But the closer engineers came to mastering rivers, the more they discovered a difficult truth. Changing the landscape was not the end of the challenge. It was the beginning of a new one. Because once the steam giant entered the field, the question was no longer whether humans could reshape rivers. The question became what would happen to everything and everyone standing in the machine's path. The steam giant was not a machine that simply dug. It was a machine that transformed the relationship between humans and the earth. Standing beside one, a worker would not have seen a tool. They would have seen an industrial creature built from thousands of moving parts. Steel structures stretched across the worksite. Large arms extended outward. Cables moved under tension. Steam pressure powered mechanical systems. Every section of the machine existed for one purpose: to remove the landscape piece by piece. The process began with power. The machine required enormous energy to move its own weight before it could move anything else. Steam engines converted heat into mechanical force. Boilers produced pressure. Pistons transferred that pressure into motion. Gears multiplied force. Cables carried loads. The machine turned invisible energy into physical destruction. The earth beneath it was the target. A riverbank, a hill, a field, a section of ground that had existed for thousands of years. The machine approached it slowly, not with speed, with certainty. The excavation cycle was repetitive but precise. The digging mechanism entered the earth. The bucket or shovel cut into the material. The machine lifted the load. The structure rotated or moved. The material was released. Then the process began again. Each individual movement seemed small compared with the size of the machine. But repetition changed everything. One bucket became thousands. One day became months. One project became a transformation of geography. The machine's true power was not a single action. It was persistence. The steam giant could continue working when human bodies could not. It did not become exhausted. It did not need sleep. It did not suffer from cold, heat, or fatigue in the way workers did. Its rhythm was determined by fuel, maintenance, and engineering limits. That was the revolution. Human labor had always been restricted by the body. The machine was restricted only by the system supporting it. Fuel, repairs, organization, supply. The steam giant became the center of an entire industrial operation. The machine itself required infrastructure. Fuel had to arrive. Parts had to be available. Workers had to be trained. Transportation systems had to support it. A machine capable of moving rivers could not exist alone. It depended on an entire network. Inside the machine, operators controlled the process. Their work required concentration. The scale of the equipment created unique challenges. The operator was surrounded by machinery, but separated from the ground being changed. The machine was so large that direct observation was difficult. The operator had to understand movement through instruments, experience, and communication. A small mistake could become a major problem. The machine could not react like a human. It moved slowly. It carried enormous force. Stopping or changing direction required planning. The operator had to think ahead. They were not simply controlling a shovel. They were controlling a moving industrial system. Around them, maintenance crews worked constantly. A giant machine experiences giant stresses. Steel bends, cables weaken, mechanical parts wear. Steam systems require attention. Every component had a lifespan. Every component could fail. The machine's size created an illusion of permanence. But the truth was different. The larger the machine became, the more important maintenance became. A small failure in a small machine might stop one task. A failure in a steam giant could stop an entire project. This made the workers who maintained it essential. They knew the machine intimately. They recognized unusual sounds. They noticed changes in vibration. They understood when something was wrong before a complete failure occurred. The machine was advanced, but it depended on human knowledge. The excavation environment added another layer of difficulty. The machine operated in constantly changing terrain. The ground itself was being removed. The workplace changed every day. A stable area could become unstable. A safe route could disappear. A familiar landscape could become unrecognizable. Workers had to adapt constantly. The machine created the conditions it operated in. Every bucket removed another piece of the world. Every movement changed the next movement. The steam giant was not working on a fixed landscape. It was creating a new one. This was especially challenging near waterways. A river is not simply a line of water. It is a living system. Its depth changes. Its flow changes. Its banks shift. When engineers altered rivers, they had to understand forces larger than the machine itself. The excavator could remove earth, but it could not completely control what water would do afterward. The machine could create a channel. Nature would decide how that channel behaved. This created a constant relationship between engineering and uncertainty. The steam giant represented human control. The river represented natural force. The two met in the excavation zone. The machine's physical presence dominated the landscape. It moved slowly across the earth like a mechanical animal. Its movements were heavy and deliberate. The sound became part of the environment. Steam escaping, metal striking, engines working, material falling. The machine announced its presence long before anyone saw it. Workers experienced this environment every day. They felt the vibration. They heard the machinery. They worked beside forces far beyond individual strength. For some, the machine represented progress, a sign that technology could solve problems that had limited civilization for centuries. For others, it represented a new form of danger, because the machine that could reshape the world could also harm anyone who stood too close. The same systems that created power created risk. A cable under enormous tension could fail. A structure could collapse. A moving component could trap a worker. Steam systems could malfunction. The dangers were not always dramatic. Often, the greatest threats came from routine. A familiar machine, a repeated task, a moment of lost attention. Industrial accidents frequently happen not because workers do not understand the danger. They happen because humans must work around danger every day. The steam giant demanded respect. It was too powerful to ignore. The workers who operated it learned this quickly. They understood that the machine was not a simple piece of equipment. It was a force, and controlling a force always carries consequences. The steam giant changed rivers. It changed trade. It changed nations. But every transformation required people willing to stand beside the machine while it worked. And the deeper these workers entered the system, the more they discovered that the greatest challenge was not moving the earth. It was surviving the machine that moved it. The steam giant was built to reduce one of the oldest burdens in human history: physical labor. For thousands of years, people had moved earth with their own hands. They dug canals, cleared rivers, built roads, raised walls. Every major civilization depended on human effort to reshape the world around it. The great excavator promised a different future, a future where machines would carry the impossible weight, where steel would replace muscle, where steam would replace exhaustion. And in many ways, it succeeded. But the machine did not remove human sacrifice. It changed its form. The workers who operated these machines entered a new industrial world. They were no longer spending every hour lifting, carrying, and digging manually. Instead, they worked beside a force powerful enough to move thousands of tons. Their bodies were not carrying the entire burden, but their lives were now connected to machinery that could fail with devastating consequences. The danger began with scale. A small machine gives a worker a chance to react. A giant machine often does not. When thousands of tons of steel begin moving, the forces involved are beyond human ability to stop. A worker caught in the wrong place was not facing a tool. They were facing an entire industrial structure. The machine required constant attention. Operators monitored movement. Mechanics inspected systems. Laborers worked around the excavation area. Everyone depended on everyone else understanding the machine. A single mistake could affect many people. The larger the project, the greater the consequences. The steam giant transformed the workplace into a system where safety depended on coordination. Communication became as important as physical strength. Workers needed to know where the machine was moving, when it would move, what areas were dangerous, what conditions were changing. The machine created a workplace where awareness was survival. But awareness did not eliminate risk. The excavation environment was constantly unstable. The machine changed the land while workers were standing on it. A riverbank could collapse. A wall of earth could shift. A section of ground could weaken after being altered. The machine was powerful enough to reshape nature, but the ground beneath it remained unpredictable. Workers lived inside that contradiction. They operated a machine that represented human control over the environment. Yet they remained vulnerable to the environment itself. The conditions were also physically demanding. Large industrial projects exposed workers to weather, noise, dust, and exhaustion. The machine may have replaced manual digging, but workers still performed difficult tasks. Maintenance required physical effort. Repairs required climbing, lifting, and working around dangerous components. The machine reduced some labor while creating new forms of labor. The operator replaced the shovel worker. The mechanic replaced the repair worker with simpler tools. The technician replaced the person performing basic tasks. Industrial progress rarely eliminates work completely. It transforms what kind of work is required. The psychological burden was another hidden cost. Operating a machine of enormous power meant carrying enormous responsibility. A worker knew that a mistake could affect an entire project. The machine responded slowly. A poor decision made seconds earlier could become impossible to correct. The operator had to think ahead constantly. The machine was powerful, but the person controlling it carried the responsibility. There was another contradiction. The steam giant helped create prosperity. It opened waterways, improved transportation, connected regions, allowed goods to move faster. It helped nations grow. But the same projects that created opportunity often demanded sacrifice from the people building them. Workers spent months or years in industrial environments where the public rarely looked. The finished canal became a symbol. The completed river route became a celebration. The machine became part of the achievement. But the workers who operated it often disappeared from the story. History remembers infrastructure. It remembers dates. It remembers engineers and governments. It does not always remember the people standing in the mud beside the machine. This is one of the great patterns of industrial history. The final creation appears permanent. The labor behind it disappears. The bridge remains. The workers vanish. The railway remains. The crews fade. The canal remains. The excavation teams become names in old records. The steam giant left behind a similar legacy. It became associated with transformation, a symbol of engineering confidence. But the people who made that transformation possible carried the hidden cost. Eventually, the world that created the steam giant began changing. New technologies appeared. Fuel systems improved. Diesel power replaced steam in many industries. Electric systems became more efficient. Construction methods evolved. The massive steam machines that once represented the future became outdated. Some were dismantled. Some were abandoned. Some became historical artifacts. The machines stopped moving. But the landscapes they created remained. The rivers still flowed through altered channels. The trade routes still existed. The nations that benefited from improved infrastructure continued using it. This created the final contradiction. The machine disappeared. The consequences remained. A steam giant could vanish into rust and silence, but the world it helped create continued. The rivers it changed still carried ships. The cities it supported still existed. The economies it strengthened still depended on those connections. Its legacy was not only the machine, its legacy was the new world built around it. Today, when people see the remains of these industrial giants, they often see engineering achievement. And they should. Because the machines were extraordinary. They represented imagination, skill, and ambition. But they also represented something else. A reminder that progress always has a human side. Behind every massive industrial achievement are people who operate it, people who maintain it, people who accept the risks. The steam giant did not build new nations by itself. It did so because thousands of workers stood beside it and made it possible. The machine moved rivers, but human beings carried the weight of making that movement happen. For a time, the great steam giants seemed permanent. They dominated construction sites. They transformed waterways. They moved more earth than earlier generations would have believed possible. Governments invested in them. Companies depended on them. Engineers designed projects around them. The machine was not merely equipment, it was infrastructure in motion. And yet, like every industrial system, its dominance depended on a specific moment in history. The steam giant thrived during an age when steam power represented the pinnacle of mechanical capability. Coal was abundant. Steam engineering was well understood. Industrial economies were expanding rapidly. The machine fit perfectly into a world obsessed with scale. But industrial history is a story of replacement. Every breakthrough eventually becomes an obstacle to something newer. The same innovation that transforms one generation becomes outdated in the next. The steam giant was no exception. Its greatest strength was also its weakness. It was enormous. Its size allowed it to move vast quantities of material. Its size also made it expensive, complex, difficult to maintain. The machine required large crews, constant fuel supplies, extensive repairs, massive support systems. As long as the benefits exceeded the costs, these requirements were acceptable. But technology continued advancing. Internal combustion engines became more reliable. Diesel-powered equipment offered greater flexibility. Electrical systems improved. Hydraulic machinery introduced new possibilities. The industrial world discovered that it could achieve similar results with machines that were smaller, faster, and easier to operate. The change did not happen overnight. For years, steam machines and newer technologies existed side by side. Engineers compared efficiency. Contractors calculated costs. Operators adapted to changing equipment. Gradually, the balance shifted. The future no longer belonged to steam. The future belonged to systems that could deliver more work with fewer limitations. The giant excavators that once symbolized progress began disappearing from active service. Some were dismantled for scrap. Their steel was reused. Their components were recycled into new industrial projects. Machines that had helped create waterways and infrastructure became raw material for the next generation of technology. Others were simply abandoned. In remote industrial landscapes, enormous structures remained standing long after their usefulness ended. Boilers rusted. Cables deteriorated. Metal surfaces weathered under decades of exposure. Vegetation grew around foundations. The machine slowly became part of the landscape it had once transformed. There is something haunting about abandoned industrial equipment. A silent factory, an empty mine, a giant excavator frozen in place. These structures remind us that industrial power is temporary. At their peak, they appear unstoppable, but eventually, they become relics. The steam giant followed the same path, yet its influence survived long after its machinery stopped moving. The waterways it helped create continued functioning. The channels remained open. The transportation networks endured. Ships continued traveling routes that would not have existed without large-scale excavation. Cities continued benefiting from connections established generations earlier. Entire regions remained shaped by decisions made during the age of steam. In this sense, the machine never truly disappeared. Its physical form faded. Its effects remained. This is one of the defining characteristics of infrastructure. A machine may be temporary. The world it creates can endure for centuries. Many of the waterways built or improved during the era of giant steam excavation still influence commerce today. Modern vessels move through routes originally made possible by mechanical systems that no longer exist. Contemporary economies benefit from engineering work completed by workers long forgotten. The machine vanished. Its consequences remained embedded in geography. Its legacy is also visible in modern excavation technology. Today's equipment is more efficient, more precise, more powerful in many ways, but it exists because earlier engineers proved that large-scale mechanical excavation was possible. The steam giant established principles that future generations refined. Every modern earth-moving machine carries part of that inheritance. Yet the deepest legacy of the steam giant is not technological. It is historical. The machine revealed what industrial civilization was willing to attempt. It demonstrated a belief that natural barriers could be overcome through engineering. A river could be redirected. A channel could be created. A landscape could be redesigned to serve economic and political goals. This confidence reshaped the modern world. But the steam giant also exposed the costs hidden behind that confidence. Workers accepted danger. Communities adapted to industrial disruption. Natural environments were altered. The machine delivered benefits, but never without consequences. That is why these machines remain so fascinating. They are not merely examples of engineering success. They are evidence of a larger story, a story about ambition, a story about power, a story about humanity's determination to reshape the world in pursuit of progress. The 9,000-ton steam giant helped dig rivers and create new nations. But the machine itself was never the true subject. The real story was the problem that demanded its creation, the industrial system that depended on it, the workers who operated it, and the world that emerged after it finished its work. Today, many people cross canals, navigate waterways, and benefit from transportation routes without ever considering how they came into existence. The infrastructure feels permanent, natural even. But beneath those waters lies the memory of an era when steam-powered giants attacked the earth with iron, pressure, and relentless determination. Their engines have fallen silent. Their steel has rusted. Their crews are gone. Yet the rivers still flow where engineers wanted them to flow. The channels still carry commerce. The nations shaped by those waterways still exist. And hidden beneath the surface of modern life is the legacy of a machine that proved a remarkable and unsettling truth. Once humanity learned how to move a river, it became willing to remake entire landscapes in pursuit of the future.